Kinematics 7. Freely falling bodies. In the absence of air resistance, it is found that all bodies at the same location above the Earth fall vertically with the same acceleration. If the distance of the fall is small compared to the radius of the Earth, then the acceleration remains essentially constant throughout the descent. This idealized motion is called free fall, and the acceleration of a free-falling body is called the acceleration due to gravity. Gravity is G, and in Denmark it equals 9.82 meters per second squared. Here is some test that is made in a air-filled tube. We have a piece of rock and a piece of paper, and the piece of rock is falling much quicker, much higher acceleration than the paper due to air resistance. If we evacuate the tube, that means there's vacuum in it, then they fall at the same acceleration, which is G equals 9.82 meters per second squared. An example. A stone is dropped from the top of a tall building. After 3 seconds of free fall, what is the displacement y of the stone? We have a drawing. We have decided what direction is positive and what direction is negative. And we can write up our variables, our displacement, y, that's the question, our acceleration, minus 9.82 meters per second squared, our initial velocity, 0 meters per second, and our time, 3 seconds. So we have to choose an equation where we have those variables and where we can find our displacement. That's the fourth equation, that's called initial velocity multiplied by time plus 2 multiplied by our acceleration multiplied by time squared. This is a 1. Now we just put in some numbers, and we can see here that the first part of the equation doesn't do anything to it, because 0 meters per second multiplied by 3 seconds, well, that's 0 meters. So our displacement is half of our acceleration multiplied by time squared. Our acceleration here is the direction of our acceleration is downwards, and our displacement is counted upwards because we have plus pointing up. So that gives us that our displacement is minus 44.1 meter.